Hi everyone, so welcome. In this video I'm Cyprien from FA for All, and today I'll start from scratch to show you how to do stress linearization. So stress linearization is a function that is used a lot if you're analyzing pressure vessels, for example, and basically when you have 3D models but you'd like to extract bending stresses or things like that from 3D elements. So it's not a data you have by default, so you need functions called stress linearization to do that. So let's start with Salome-Meca, and I will start with building the model from scratch because I like to show you all the process, and at the same time you can learn how to build a very simple geometry inside Salome-Meca. So I'm opening the geometry module and I will create a simple shape. So let's go into the XZ plan. Okay, this is not exist. Okay, we can have this plane as well. It's the same. Okay, let's start by so the kind of model I want to build is basically the 1/4 of a pressure vessel cap, let's say. So basically some kind of half part of a sphere. So to do that, let's draw first the points. So okay, I will use the meter unit, so that will be something important afterwards when I go to the analysis. So let's make the points first. So in the y-axis let's do one 0.2, apply, and one 0.18. so I'll say basically that the thickness is like 20 millimeter, 2 centimeter of thickness. And now okay, let's expand again. Where is my point? Okay, I don't see it anymore. Okay, let's just say that my point is in y-axis and I have in z-axis same 0.2 and 0.18. Apply. Now let's take a look. Okay, now we see them again. So I have 4 points like that. So now let's link those points and let's create a face. So let's create two segments to link the nodes here and here. Okay, selected the wrong nodes. This one and this one. Apply. So I have, okay, I selected 2 times the same. Okay, apply. Okay, I have one segment. Now let's create the second one. Okay, let's create 2 arcs. So for that I'll use the create an arc function. I'll use the second method, and let's select the center point as O, and start point. Okay, the points are hidden, so I need to reactivate them like that. Okay, so basically, okay, so it's selected automatically the right point. So apply. I have my first segment. Now let's create the second segment, the second arc, sorry. Okay, apply and close. Okay, I have 2 arcs and 2 lines, so I can hide the vertices, and I can basically create my face. So new entity, build a face, and let's select all of that, and now okay, apply and close. Now I have my face. So now let's make it revolve around z-axis in order to create my model. So for that, generation, and we have an option called revolution. So select the face. Now we have to select the axis, so we can select it from the tree here. So we're seeing already a preview. So I want 90 degree and I want it in the other direction. So okay, like that. Apply and close. Okay, now I got my model basically. Okay, now we have to create the groups, the geometry groups that will be used to assign the loads and everything. So let's do that. So I need one solid group. Okay, I select the main shape. I need one solid group for the whole model. So let's call it volume. Apply, and you see that it appears here in the tree like that. And now I have to add basically one group for all the surfaces. I will have nothing applied to the external surface, so I won't need this one, but I need these two to create a symmetry and that one to block it basically. So let's do that. Face, let's select this one and let's give it a name that I will remember. So let's call it sim x and z. Let's do the same with this one. Let's call it sim yz. Okay, I think I have to remove that. I have to select the right face. Okay, this one. Oh, no, it's not the right one. Let's rotate them all. Okay, 25. Okay, that's it. Apply. And now I need also one for the face here. And this one I'll call it, so it's not a symmetry condition, so I'll call it face x, y. I have something incorrect, so let's do it again. Select the face. I think I didn't select the main shape. I don't know why. Revolution. Okay. Sometimes it doesn't look like you want, but that's normal. Okay. Joy of open source. Apply. And now the face, the internal face here. Let's call it inner. Okay. Apply and close. Okay, that's basically all I need. Okay, now something more maybe that I will need is if I want to create my my stress linearization in this area of my model, well, I will need to extract the position of this. So the best is probably to create a segment here in the geometry, and I will use this segment later on when I associate all of that to create my cutting line. So let's do that. Let's create 2 points. So if you remember, this is 0.18. So x, sorry, y. No, not y, x and z. So x 0.18 and z 0.18. Okay, now I'm getting the point here, which is too far. So to get it here, basically, let's do something else. Let's copy the edge here. That will be much easier. Let's hide that. Let's display again line 1 and line 2. and I think I can rotate this edge in this plane. Probably there will be a function like that, so let's find it. Operation, transformation, rotation, I think. Yeah, probably this. And I want to rotate around an axis. Okay, we can choose that, and the object will be well, this line 1, maybe, I think line 1, and the axis will be the y-axis. Okay, y-axis with an angle of 45. Where does it put my segment? I don't know. There is a preview, but I don't know why I can't see it. Create a copy. Maybe because my line 1 is hidden, I don't know. I don't know why it's not showing. Okay, let's see where is that. Okay, it's not exactly. The position is a bit strange. I don't know what happened. Okay, this is the line 2, that's why. Okay, so it put the segments over there. It's not exactly where I wanted, so maybe I did some mistake here. Let's delete that. Okay, then you know what? I'll see later how to do that. I'll first build them all, and then I will extract the position later on once the model will be ready. So now I have all the groups. I may lack some group for the meshing. So for the meshing, I want to group these two segments and the two arcs to create a submesh later on. So let's just create two last groups. So this will be segment groups. Okay, belonging to this. Let's select this and this one too. It's not a sub shape because this is activated. Okay, I will hide that. Okay. Okay, let's try again. Let's hide all the lines and arcs and display only the solid. Sometimes it's a bit not easy to do. Okay, and the main shape is that, and let's select this and this one. Okay, and let's call it D. Okay, I don't know why I got the error message. I think I clicked twice on the button, that's why it works basically. Okay, and let's create the arcs. Okay, and let's create arcs. Okay, you will see right away why I did that, because now I'm going to the meshing phase. So let's go to the meshing. Let's display my solid. Okay, it's like that. So now there's a little difficulty here. Basically, you have a lot of options for the meshing. So if you remember, you have to go in create a mesh, and well, basically you could use this NetGen 1D 2D 3D, but then you will get a meshing which is not good, which is tetra, and really not the kind of thing you want for this kind of model. In this model you want to build a really good mesh layer. So how do you do that? Well, if you use this hexahedron, then it becomes a bit difficult to define the other types. Well, basically it's not working exactly like I want. So what I found the solution is to mesh only this surface, and then to revolve it around this axis manually to create the mesh. So let's do that. Create a mesh, and let's create a quadrangle mapping of, so here you have to choose the right geometry. So let's mesh the face basically here, and you see it becomes 2D. So on the hypothesis, okay, let's just choose this one, and let's give it a number of segments. Let's give it 15, default option. Okay, and now if I mesh it like that, it will give me 15 division in the thickness, which is not what I want. So if I want to mesh it like that, that's where I'm basically using the groups I just defined. So I will have to create sub-meshes, and here I select the group, so the group D, and here, so in the thickness I want, let's say 5 elements. Maybe it's a bit too much, I don't know, we'll see. 5 elements, and let's propagate this. So propagation means that the hypothesis here will be used on the other side. Okay, apply. There was a small problem, I think. I know why my submesh was not created. So let's try again. Geometry, face. Okay, maybe I have to select. I think it's okay. Mesh 1, geometry face, quadrangle mapping, 1D wire discretization, and with this hypothesis, geometry object is not a subshape of the shape to mesh. Okay, okay, I understand. That's because the D basically that I'm choosing here is not belonging to the face, so I should create a group on the face rather than on that. So let's come back to the geometry, and let's create those 2 groups on the face, on this face here. So let's delete that. Yep. New entity, group, create a group, main shape, face, segment, and let's select this segment and that segment, D. Oh my god, what is happening now? I think the arc, there's again a problem with selection somewhere. Okay, let's try again. Add. Maybe let's call it D2. Maybe it's because of the name. Okay, it works. And this segment, add arcs 2. Okay, let's come back to the mesh. So I was here creating my submesh. Create submesh. Mesh 1, geometry, and now the groups are under the face, which is, so it should be working. Number of segment, propagation, apply. Okay, now it works. And let's create a second group for the arcs. And for the arcs, let's say I want, well, I have 15 by default, so it should be divided by 15 segments. Let's say that I don't need 15. Let's divide by 10 segments. Maybe we'll see. Okay, I created 2 groups. Now let's just try to mesh all of that. Compute. Okay, it's not working. Okay, actually it's working. It's working. It's exactly what I wanted. Okay, so remember, I'm creating a 2D mesh here. Now the challenge is to get this into 3D, right? So I want to revolve this around this axis. So to do that, I'll have to use the mesh operations transformation. No, not that. Okay, I don't know what happened. My mesh just disappeared. Okay. Controls. So I think there should be an option, revolution. Oh yeah, I think it's that. Revolution. What do I want to revolve? Well, everything. So object. Okay, select my mesh. Edges. Well, select also this. Okay, this one too. Faces, also the same. And for the axis, we want around z-axis. So the point should go through the origin, 0, and the vector should be along z-axis. Now we can see a preview, so now it's going in the opposite direction. Let's use angle of 90 degrees, and let's cut it, let's do it in 10. So you see that it's doing what I want, but it's I want the opposite, so let's try minus. Okay, and it works. So now it will extrude my mesh like that, extrude around the axis, so basically revolving. Okay, and now I got my mesh. So now unfortunately it's not totally finished because I need to create the groups for the mesh. So that's kind of the boring part, but you see that you will learn a few things also how to do that, because I extruded the mesh from this face, but the solid that I created before is not really associated to that anymore, because I didn't mesh from this solid directly. So probably if I choose create groups from geometry, I'm expecting that I will have some problems. For example, if I select the groups here that I created, you see it doesn't add up basically. So I cannot use this function anymore to create the group. So that's a bit That's kind of a problem. So how do I create the groups for the mesh? Well, don't worry, I will still use that. But this time, let's use create groups, and let's create the group manually. So let's select the mesh, mesh set. Let's create face group and enable manual edition. And you see you have the option for filter. So we'll use the filter to select the mesh we want. So let's add a filter. And here you have, I think you have something with geometry, belong to geometry. So let's use that. And I think we should be able to select this. So if I select SimXZ, apply and close, and now you see that those elements are selected. So I can add them manually here. And I just have to give the name SimXZ. So that's a bit annoying because you have to do it one by one. So let's try to do that quickly. Okay, so that's basically it for the different groups. Okay, so now that I created all that, let's do the analysis. Let's go in Master Study. And let's create a stage. Let's read the mesh. Okay. Let's define the direction. So I will assign a pressure to the area here. So I need to give a direction to this surface. So I'm using this function orientation po 3D, which means oriented skin. Change the name to have the same name. Both functions need to have the same name. Let's select group of element inner. Okay. So some people ask me, how do you know the orientation of the elements, basically? Because you choose an orientation, but you don't even know what is this orientation you have chosen. Well, basically the orientation you choose is the orientation of the elements which are inside this group. And if you want to know exactly what is this orientation, well, you can see it for that. Let's go back into this and let's display only inner face. And if you right click, you have orientation of faces. And if you see here, you'll be able to display direction. So you see you have small arrows which indicate you in which direction it's oriented. So now it's oriented towards inside. So I will have to apply my pressure, I suppose, with a minus sign to have everything oriented towards exterior. Okay, so let's go back in Aster Study and let's continue. So now I need to assign finite element model, and everywhere, so it's a mechanical model in 3D. Oh, sorry, my mouse is very sensitive, so okay, that's it. Let's define a material and assign it. So linear isotropic material. And here, be careful, the unit you're using should have 30 more, because I'm using meter unit, so it should be defined in Pascal, not in MPa. 0.3. Okay, that's all I need. And assign this material to my model. Okay, boundary conditions. So assign mechanical load. Let's enforce degree of freedom. So group of elements, and here I'm selecting symmetry XZ. Okay. And here I will fix the displacement Y on this face. So remember that solid element only has 3 degrees of freedom, so that's why I only need to fix 1 degree. Group of element YZ. I think I created, oh my god, I created 2 times the same group. Okay, I have to come back briefly to this, and I'll have to create again a group. So let's see. So it was symmetry YZ. This one. Symmetry YZ. So mesh, create group, face, select the mesh set, enable manual selection, set the filter, add belonging to geometry, and here click here and select this, apply and close, add, and this is symmetry YZ. Okay, got it. Now let's go back to Aster Study. Now it's important to remember that if you want the groups to automatically update here, so you see it has been added. In the reader mesh function, you need to link with the to the mesh module directly, not with a mesh file. If you link with a mesh file, you'll have to export again your mesh, otherwise it won't appear here automatically. So that's a trap that you may fall into in some cases. So dx 0. Okay. Okay, and I forgot to block the remaining face. Face X. Okay, this one. And this one I will fix it with all degrees of freedom. Okay, and let's call it BC So I know that's the boundary conditions, constraints. Now let's assign the loading. So let's call it press, like pressure, and let's use this one, press rep. To the inner face. So here, if I'm not mistaken, the direction should have a minus sign, and this is not in MPA, this is in PA, so I need to add 30 more. So now I'm adding minus 100 MPA. I'm not exactly sure if it's too much or not, so we will see in the results. But anyway, the purpose is just to show you how to do that. Okay, analysis, static, mechanical, field, model. Let's add the loadings, pressure, boundary conditions. Okay, and that's all we need. Now I want the stress result as well, so let's add a calc shell, and here I need to have the same name than my stat-meca function, otherwise it won't work. And let's activate two kind of things. First, stress, so contrainte means stress in French, so I want sigma L no, which is sigma, basically the stress sigma at the element node, and I want von Mises stress, so I have to go in the criterion and add sig L no, which will give me the von Mises stress. Okay, and the last thing I need is set output results to print out the results. So before I show you how to do the stress linearization, we'll check out the result and make sure that everything is working right. So let's create a file here for the output. So let's call it linear.rmed. So your result file should always be something like rmed. Let's assign the results. Don't forget this step, otherwise you'll get nothing in the visualization. Okay, and I think I didn't save my model, so let's save it in the same place. Linear, let's call it linear. Okay, and now it's time to launch the solver and praise that everything works. So first time usually you get something red. Oh, I'm getting green. Perfect, so it works, no problem here. That's amazing. So I'm getting green. Let's take a look at the results to see what we get, if this is what I expect, and then I'll show you how to linearize the stress in the thickness. Okay, the visualization is a bit strange. Okay, so let's take a look at displacement. Okay, I'm getting displacement seems rather small, so maybe the load wasn't too big after all. Let's take a look at the stresses. So for that I need to add a filter, mechanics, L no, fill to surface. Okay, okay, I'm getting the stress. And let's take a look at, so this is sigma sic alno font measures. Okay, I'm getting something around 664, so I think I have a huge stress here around this edge. So I don't know, maybe it's over constraint of the model in this area. But anyway, that's to show you how it works. So now the model works basically. So let's see how I can extract and linearize this on this area, on the thickness. So let's go back to Aster Study, and let's go into, now how do I extract, how do I create this linearization? Well, for that I'll have to go in the post-processing option and use this function, macro linear coup. So this is the function that will help me to linearize the stress results. And these functions, so select the result. So it outputs a mesh file in another format. So you can call it as you want. So let's call it lin.med because it's a mesh file. You can really call it as you want. And now we need to add the cut line, linear coup. So this is the cut line on which I will linearize the stresses. Let's take a look. Okay, so you see that you have several methods here. You can select an arc, a group of element, group of nodes, or a segment. So a segment is basically you select 2 points, anyone from the coordinates, and you can draw the line. So that's what I'll do. The number of points is the number of points you want on your linearization line. So let's choose 15, for example. And the coordinates of origin, so there's only 2, but you can add third one, and basically this is the coordinates of your start point of the line and of your end point. So you just have to enter the value for the 3 axes x, y, and z of those coordinates. So in this case here, I'll need to try to extract the value of those nodes. So how to do that? Let's go back to my mesh module. Let's try to determine, let's say, what is the value of this segment. So I want what are those nodes basically here. So several options. If I select a node like that, okay, now I'm getting coordinates. So that's basically the coordinates. So this one is 0, and this is x. So let's copy that. Let's copy that, and let's go back to Aster Study. So this and 0, and let's go back to this, and let's do the same trick. So I think I selected this one. Yeah, so now let's select this one, and now I'm getting this value. So let's copy that, and this is 0. Okay. Now what do I need more in this? Well, you need I think you need the resultant, if I'm not mistaken, or maybe not. You need the direction. So the direction is what was it? I forgot. Yeah, this one you don't need it. So direction here, okay, you need to, okay, it's direction of your line, the orientation basically. So you can enter 0, 0, 1, for example. Okay. And what do I want to be linearized? So here you have a lot of choice. So let's say I want seek I'll that I already have in my result. So you should make sure that you're selecting here a result that you already calculated, otherwise you will not get anything. And you see that the name is table. So basically the results you get are saved into, are created into a table. But now if you want this table to be saved into a file, you need to use the output option, imp table, and here you need to call it, let's call it coup, and yeah, and let's give it this table, and that's all. Okay, now it's time to see if it works. So okay, so I'm getting some, it works from the first try, it's really amazing. Now you see that I have a text file coup that was generated. So if I open it, so results are a bit messy. It's very large, that's why you see a lot of mess like that. But you see that if you extend, so it's basically a table where you have, okay, like that is better. So you have apps curve, which is which is basically the curvy line axis, and you have font misses here. So how would you plot this along that and have a graph of that? That's something you may want also to do. Well, fortunately, it's not so difficult to do. You have to go here and output. Okay, actually, I can use the same function, imp table, but instead of saying I want a table, I will use this xmgrace. So it will export directly to xmgrace, and I need to change the name of the file, and let's call it coup.agr. I think it's the name of the grace file. So the grace should be installed before on your computer, so that's an external library. So if you don't have it, you can search for a package manager like Synaptics, and you can install it. You install Grace, and you will have it. And now what do? You need to give it some parameters you want. So the parameters are here, parameter name. So add 2 parameters, and you have to take those parameters from the file that I printed here. So let's say that I want this apps curve. So let's copy that in function of font misses, fimis. So apps curve, fimis. Okay, and I think that's all I need. So let's run again. amazing, 3 greens, one after another. And now you see that the file exported is called coop.agr. So when it has this extension, you can open it directly with the Grace library, and you're able to visualize like that your stress linearization. So your stress along the line, the cutting line that you created. Okay, I think that's all for this video. I hope you learned a lot how to linearize the stresses with Codaster and Salome-Meca. And if you like the video, don't forget to put it a like, and also let me know if there's something more you want to know, or maybe you need some precision, some details about some things I'm talking about, or anything more. So let me know, and thank you very much for watching. So if you're on YouTube, you'll probably find the link to the article and the next videos inside the description. Otherwise, you can go on my blog feforall.com and click in the category open source FEA, and you'll find all the articles I wrote about open source FEA and the previous videos inside this category. So thank you for watching. I hope that you learned a lot and that you will learn a lot using all the videos that I am sharing on my blog. So if you like those videos, please help me to share them with your friends and other engineers. And also, please let me know what you think in the comments. It's always great to have some kind of feedback, and if you have some ideas of things you would like to learn or do with FEA, please also let me know. Thank you for watching again.